Just testing my setup. I'm just testing my setup. When I was 14 or 15, I went through a phase where I was really into skateboarding. As a beginner, my friend and I would just ride around his neighborhood, trying out our skills. One day, we decided it would be a great idea to find the biggest hill in his neighborhood and ride down at full speed. At the top of the hill, I had a large amount of potential energy stored up. The idea was that at the bottom of the hill, I would have transferred most of that potential energy to kinetic energy, resulting in a high skateboard speed. This idea is pretty common in physics mechanics. What you may not realize is that the same principle applies in electromagnetics. Now, instead of in terms of elevation or height, we're going to talk in terms of voltage. The voltage difference V between 2 points in a circuit represents the amount of work required to transfer one unit of charge from one location to the other. This is called electric potential. It turns out that the electric potential, or voltage, measured between 2 points is equal to the voltage at one point minus the voltage at the other point. This can also be calculated by taking negative the integral of the electric field dotted with a differential length traveling along a path from one point to the other. What's neat about this is it doesn't matter what path you take between the 2 points. The voltage will be the same. One last extension of this idea that we see in circuits is what we call Kirchhoff's voltage law, which says that the sum of all voltage rises and voltage drops around a closed circuit is equal to 0. In terms of the equation that we gave just a moment ago, this means that the integral around a closed contour of E dot dl is equal to 0 as long as E is an electrostatic field, meaning that it doesn't change over time. For the electrostatic field E, that means that this field is conservative, or in other words, it follows the law of conservation of energy. Now, to conclude my story about the skateboard, what I didn't know at the time was that there was some loose gravel at the bottom of the hill. This gravel got caught in my wheels when I hit the bottom of the hill, so I went from a relatively high speed to a fairly abrupt stop, transferring all of that energy directly into my shoulder. I still have a scar from that incident today. That's what makes this a memorable reminder for me about potential energy. Thanks for watching. We'll catch you next time.